Note this. If you take an expression that is not a factor, for example, let's say x plus 2, and we equate it to 0, that x plus 2 equals 0, then we find the value of x will be -2. If we take this x as -2 and insert it into this expression, the result we'll get, which is not 0, will be the same as the remainder you will get when you divide x squared minus x minus 12 by x plus 2. If you take x as -2, let's write the expression x squared minus x minus 12. Taking x as -2, we have -2 squared minus -2 in bracket, x is -2 minus 12. -2 squared is -2 times -2. That will give us +4. Then you have negative, 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 it will be positive. Then you have 2 minus 12. 4 plus 2 is 6. Then you have -12. 6 minus 12 would give you -6. You see, the result is not 0. Unlike when we take x as -3 or x as 4. X equals -3 and x equals 4 are both derived from factors of this expression. And when you take them and insert them into the expression, you end up with 0. Unlike when you take x plus 2, which is not a factor of the expression, and you equate it to 0, thereby getting a value for x, which is -2 in this case, and inserting it into the equation, the result won't be 0. Like in this case, you have -6. Now, to see how this really relates to the division of polynomials, if you take x squared minus x minus 12 and you divide it by x plus 2, what you get will be the quotient, which is an algebraic expression, remainder -6. Note that the remainder you get when you do this division is the same as the result you get when you take the value x plus 2, equate it to 0, get the x value, and insert it into the equation. You can see that both the result and the remainder are the same. This concept applies to all non-factors. Note that in polynomial division, this is called the dividend. This is called the divisor. The result is called the quotient. Then you have a remainder, which in this case is -6.